Okay, so welcome members. Now we are going to see more techniques in probability. Here we are going to see 3 different techniques. Please don't forget to subscribe to the channel. Okay, this one is telling us that in a game, a player tosses a fair die. A fair die, we say it's not biased. When 1 or 6 appears, the player wins. And when 3 or 4 appears, the player loses. Find the probability that the player wins, loses, neither win nor lose. So I'm going to start by saying WB for a win and then LB for a loss. Then meaning that now a die has 6 sides numbered from 1 up to 2. So the sample space, let us first draw the sample space. So the sample space of that die is going to be 6. So we say this player wins if 1 or 6 appear. So the probability of him winning is going to be, so the probability of 1 or 4 and then 1 or 2 appearing. So this is either this can appear or this can appear. So it has 2 chances of winning, but out of 6. So this one is going to be 1 over 3 if reduced. Because this can appear or this can appear. So he has 2 chances of either 1 or 6. So that's why I have 2 over the total 1, 2, 3, 4, 5, 6. Then probability, number 2, probability that loses is going to be now, is losing when he has a 3 or a 4. So 3 or a 4. So that means that he also has 2 over 6 chances of losing, which is also going to be a third. Then number 3, neither wins nor loses. So in neither when 1 appears, neither when 2 or 5 appears. So neither win nor lose is going to be 2 over 3. Why? I mean 2 over 6. Why? Because these ones for them they were never touched any condition. These 2 and then this 5, there's not any condition on them. So when these ones appear, it can never win and it can never lose, which is going to be also a third D. Like that. So that's how we handle this question here. When it comes to this one, a 2-digit number is formed from 1, 2, 3, 4. So we have 1, 2, 4, 5, and 7. Without repeating, this is a crucial, without repeating any digit in the number formed. Write the possibility space of the numbers that can be formed. So these are the numbers, 2 digits. We can form 1 and 2. We can form 1 and 2. I can't form 1, 1 because I'm not repeating. So I can form 1 and 2, 1 and 4, 1 and 5, 1 and 7. Then I can form 2 and 1, 2 and 1. Then I can't form 2, 2 because I'll be repeating. So then 2 and 4, then 2 and 5, then 2 and 7. Then I can form 4 and 1, 4 and 1, then 4 and 2. I can't form 4, 4, then 4 and 5, then 4 and 7. Then this one can form 5, 1, 5, 2, 5, 4. I can't form 5, 5 because I'm not repeating the number or the figure. Then 5, 7. Then this 7 can form 7, 1, 7, 2, 7, 4, 7, 4, then 7, 5. I can't form 7, 7. So those are the digits numbers I can form. Now the sample space is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's here. Our sample space is going to be 20. Okay, find the probability that a number formed is divisible by 5. So B, Roman numeral 1, probability number divisible by 5. Divisible by 5, we see here you don't have any. Also here you don't have any. We have this one here. Then we have this one, and also the other is the, do you have any? You also have 75. So the numbers divisible by 5 are 1, 2, 3, 4. So they are 4 over 20, and you can reduce it to 1 over 5. Okay, greater than 50. Remind me of 2. Probability number greater than 50. We are going to be having greater than 50. We have, I think this one qualifies. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 numbers that are greater than 50. So there are 8 over the total, which is 10, and you can reduce it to 4 over, you can reduce it to 2 over 3. 2 over 5. So you can reduce this to 2 over by 4 over 5, and that is the probability. So that's how we handle that members. Okay, now this one. A box contains 5 red pens and the rest are blue. The probability of picking a red pen is 3 over 5. Find the probability of picking a blue pen. Now we know that if you have 2 things in a box, so let red be R and B be the blue. The probability of picking a red plus the probability of picking a blue, if all of them are in one bag, when you add their probability, you should get a 1. Or this can be the probability of not picking red. Of course, we are picking the blue because we have only 2 colors. So the probability for picking red is already 3 over 5. Then plus probability of picking a blue will be a 1. So take this side. 1 minus 3 over 5. So now our probability of picking a blue is going to be 2 over 5. So this is our part A. Then part B, the total number of pens in a box. Okay. Now I know that I select X. B is the total. It means that now if I get the probability, I know the probability of red, and the number of red. So, if I get the probability of red, which is 3 over 5, times the total number, I will get 15. I will get this 15. Because red are 15. So, this is going to be 3x over 5 equaling to 15. So, cross multiply, that I'll be having 3x. Equaling to 75. Divide by 3, your x become, and divide here by 3, the side gets 25 as my number. So therefore, the total number of pens in the box are 15 pens. If they ask now the blue pens, you will just get this 15. And that's 25, that would be 10. So that's it, members. I wish you the best.